Hi everybody, welcome to Test 4 review. This is going to be a quick review, so I'm not going to have the list of questions or any formula. We just go straight to it. Right. So the first question, we are given the parametric equation, a function of t. Will give us the x and y coordinate. Right. So what we want is, first, if we have x equal to 4 cosine of t, and then y equal to 4 sine of t. If we square both sides, we have x squared, and this equal to 16 cosine squared, and y squared 16 sine squared. Combine sine by sine, x squared plus y squared equal to 16. Both of them have 16. If we factor out the 16, we have cosine plus cosine square plus sine square, which is 1. So 1 times 16 is 16. So the equation is x squared plus y squared equal to 16, which is the equation of the circle radius 4. So pretty much what we have is a circle. Right. Now we focus on the interval for t. This is for t from pi to 2 pi, so it could be from pi to 2 pi or only the second half, the bottom half of the circle. So if we have a circle, but this time we only have a bottom half. So it will be that, and it go from pi to 2 pi, so it will be in this direction. This is the starting point, the end point. So that's what we have. Right. Next we have a line segment from the end point of -3 and 1, and then 2 to 3. Just draw a little sketch here. -3 and 1, -3 and 1, and then 2 and 3. So we're going to have this segment, and let's just draw the point -3 to 1, and then 2 to 3. So what we see is that if we subtract 3 to 1, the y increase from 1 to 3, so the y here is going to be plus 2 in that direction, and -3 to 2, that's going to be plus 5 in that direction. So if we want to write the coordinate, the parametric for this parametric equation, for this one we say x, we start -3 and went up to 2, but we're not going to write 2. It will be increased by 5, and we multiply by t. If we let t from 0 to 1, then initially when t equal to 0 we have -3. When t equal to 1 we have t equal to 1, so this is 5 minus 3 is 2, so that works. The same token, we write y equal to, we start 1 and then plus 2t. So that we write the parametric equation. That from the answer might be different, but that's what we go with. This comes from the initial point, and this will be the change. We could choose different rate or different t, but this is one way to do it. Next, we have the upper half of the parabola x plus 2 equal to y squared. So without anything, when we look at this, notice that this is only the upper half. So x plus 2 equals y squared, of course, useful to have the graph. But if we want to see the graph of something like this, I just want to show that on a calculator real quick. Where's the calculator? Just a second. There's a calculator. Right. If we want to graph this equation, by the way, it's not gonna. We're gonna graph that later because right now we have y is a function, x is in that form. We'll not graph that equation. Okay, we're gonna graph later. So just put the calculator away for now. Right. So this one obvious. The easiest way to just choose y to be t, and then we just go ahead to go with that. So from here we can say x equal to y squared minus 2. Right, so that's easy. Now if we choose y to be a number, then x depends on that. So if we, for example, if we say choose y equal to t, then we have x equal to y squared minus 2 or t squared minus 2. So pretty much we have the equation x equal to t squared minus 2 and y equal to t. That's easy. Right. One thing though, we only need the upper half, meaning that the y values should be only positive. So we say t only greater than or equal to 0. Now I want to graph this. Put that here. Right. So we hit mode and go to the where saying here the function parametric polar in sequence. We keep it at the parametric. Let's see, real quick. Keep that parametric, and then when we hit y equal 2, it will be in parametric form. I'm going to enter t squared minus 2. Here it's going to be t squared minus 2, and then y equal to t. Right, and then we can graph. Oh, yeah. Let's say the t minimum is going to be 0, and the maximum, let's just say 5. You see, it's only have the upper half of the parabola, which is good. Right. Now what happens if we have something like this, the equation of a line, but we want to write x equal to some y as a function of x. So if we want to write y as a function of x, what we need to do is we solve for x. So for t in terms of x, so from here we can say t equal to x over 3, and then we can substitute this in here. So we have the equation of x over 3 plus 3. So that's what we have for those first 4 questions. Right. As mentioned before, we'll go over this rather quickly, so I don't want to just keep the list over there or the formula on that side. Right. Next 4. Well, sorry, didn't even read the question. This is find the slope of the line. So we have y equal to x over 3. So the slope is obviously is 1 over 3. Right. However, we're not going to do it this way. What we focus on is we're just going to keep this equation, parametric equation. What we do is we use y prime or dy over dx. We can say it's dy over dt or dx over dt. So pretty much we take derivative of x with respect to t and then derivative of y with respect to t, and we divide them. Derivative of y with respect to t is 1. Derivative of x with respect to t is 3. So we still have 1 over 3. And that is the formula. Dy over dx is equal to dy over dt or dx over dt. If we're going to write like and then divide dx over dt, but dividing is like multiply reciprocal. It also it's like cancel out the dt, but I'm not gonna cancel like that. Right. So this one the slope, and that is the slope. Or we can solve it that way. Right. The next 5 questions here involving the polar coordinate. We've seen this in pre-count already. What we have is x equal to r cosine theta, y equal r sine theta. So we have a triangle. So obviously x is equal to r cosine, because cosine is x over r, and then sine is y over r, so y is r times sine theta, and then we have x squared plus y squared equal to r squared, and tangent of theta is y over x. So we're going to use those. Right. So first we have this point. So we just say x equal to r cosine theta. So -5 sine of pi over 2. Y equal to r sine theta. -5. Sorry, x is cosine. Now -5 sine of pi over 2. So cosine pi over 2 is 0, so this is going to be 0. And -5 sine pi over 2, sine pi over 2 is 1, so this is -5. So if we're going to want to sketch that point, first of all, this is going to be pi over 2, so we're going to go up to this point, and then the -5 unit, so we have to go this direction. If we're going up, it's going to be positive, but because it's -5, so we go down 5 units, and we have that point, so which is good. X equal to 0, y equal to -5, so that corresponding to the point down there, which is good. Right. Next 3 questions, we're going to convert this equation into the polar equation. So remember, we're going to use those formulas. So first, the cosecant, that's not going to be anything friendly. So we're going to change that to 1 over sine. If we move the sine, multiply by sine theta on both sides, we have r sine theta equal to -9, and r sine theta is a y. So that's what we have. Kind of like the next one, if we multiply the denominator, or we just cross multiplying here, we're going to have r3 cosine theta minus 6 sine theta equal to 1, or we have 3r cosine theta minus 6r sine theta equal to 1. And once again, r cosine is x and r sine is y. So we have 3x minus 6y equal to 1. Next we're going to have that. This is sine of 2 theta. Remember, we only have the r cosine theta and r sine theta. Here we have sine of 2 theta. So if we use the trig identity, is 2 sine theta cosine theta. So we're going to use that. R square 2 sine theta cosine theta equal to 32. I would divide by 2 on both sides. So we have r square sine theta cosine theta equal to 18. 16. And then r square, what we can do is we split that into r, and we keep one of them with sine, and we keep one of them with cosine, because ultimately that is y and that is an x equal to 16. So x times y equal to 16, or we can also write y equal to 16 over x. Either way, it works. Alright, now we find the slope of this curve. There's a formula for it, but it's not worth memorizing. We just derive it from scratch. Just like number 4 we did before. Problem number 4, dy over dx is the slope, can be written as dy over dt dx over dt. Right. The only thing different here is we have r and theta. In particular, we have x equal to r cosine theta. And r is 5 cosine 3 theta. And then sine theta. X is r cosine theta, so that we times r times cosine of theta. Right. And then y is r sine theta, which is 5 cosine 3 theta times sine of theta. Now if we take derivative with respect to theta, derivative is, we use the product rule here, 5, derivative of cosine is negative 3 sine 3 theta, that's the chain rule, times cosine, and then plus 5 cosine 3 theta sine negative sine of theta. Sorry, that is derivative of cosine, so there's a negative sign here. And then derivative of y with respect to theta, 5 negative 3 sine theta times sine theta plus 5 cosine 3 theta. Derivative of sine is cosine. Right. Now we're going to substitute pi over 3 into it. So first simplify this, we have negative 15 sine of 3 theta cosine of pi over 3 plus 5 cosine of pi 3 times pi over 3 sine of pi over 3. Sorry, can't pronounce space. And then for dy over d theta is negative 15 sine of 3 times pi over 3 sine of pi over 3 plus 5 cosine of 3 pi over 3 times cosine of pi over 3. Right, I'll just simplify. Sine of pi is 0, so we don't have the first term. 5 cosine of pi is negative 1. Sine of pi over 3 is 60 degrees, so sine that would be square of 3 over 2. So we have 5 times square of 3 over 2. And then this we have cosine of pi is negative 1, so that's going to be did I forgot the negative sign here? Yeah, sorry, I forgot that. So this will be minus, and this will be minus. Alright, next. So that is 0. This is negative 1, so it will be negative 5. Cosine of pi over 3 is 1/2. Right. Now we get back to our formula here. This time we're going to have dy over d theta and dx over d theta instead of t. So we use pretty much the same. Dy over d theta is negative 5 over 2. And then the other one is negative 5 over negative 5 square root of 3 over 2. The negative 5 cancel out, the 2 and 2 cancel out, we have wait, this is negative with the negative, so that turned into a plus. Right, it has negative but negative 1, so this will be negative 1 over square root of 3, and that's what we have. Right, again, just this same formula, but we're going to write dy over d theta, dx over d theta, and x is r cosine, y is r sine, and then just take derivative. It's pretty normal. Right. Next, we just set up the integral to calculate the area of this region. So first we're going to draw it and see what we will have. Oops, sorry. I mean to move the calculator here. Alright, so to graph that in the polar coordinate, we need to set up the few things. Heat mode, make sure it's in the radiant mode, but it is going to be in polar. And we're going to hit y equal 2, it will be in polar. It's going to be 3 plus 2 sine of theta. And graph. So just like that, and nothing special. If we want to calculate, we're just going to sketch that. Matter about the graph, but look like at one and kind of, yeah, something like that. It's symmetric on the y-axis, so we only need to calculate half of it if we only choose to do so. But regardless of that, the formula for the polar, the area in polar coordinate, the area between polar curve, is given by, just going to write this, area is equal to 1/2, let's say from alpha to beta, that is the range of theta, and we have the outside function function of theta. So pretty much that. The outside function, the inner function. Right. So in this case, if we go from, with respect perspective from the center, if we look on the outside, look away, we always see the graph of the function. And again, in this case, because of symmetry, we're going to split this in half. So we say the area is equal to 2 times, because we split that in half. At the end, we should multiply back by 2. And the formula itself is 1/2. Now the outer radius, the outer function is always the graph of the function. So we just say it's going to be 3 plus 2 sine theta d theta. The function have to be square. So we take the square of this function, the inner function, just 0. So we have that square minus 0 square. It doesn't matter. It's just that. Right. And then we, in this, it's going to be negative pi over 2 to pi over 2. Right. So that's what we have. So we need 2 because we calculate only a half of it, and 1/2 here is in the formula. So that's pretty much what we have. We only need to set up the integral. We don't need to evaluate it, which is not that difficult anyway. Right. So next, we have a rose petal. So I'm going to draw that again and see how it works. It is going to be 4 cosine 3 theta. Right. Put extra parentheses. It is like a rose petal. Right. We only need to own 3 of them, which is good. However, the interval have to be a little careful. So first I'm going to sketch this real quick. Look like it's going to be like this. Close enough. Right, we bring back the calculator in a minute. Just put that here. For now, all I need to do is to set up the limit for one rose petal, and then at the end we multiply by 3. That would be more efficient, better way to do things, if you will. Even better, we can cut this in only 6, half of the petal, and then at the end we multiply by 6. That's probably what we will do. But first, let's see, we need to see where's the range for one rose petal. Alright, to do that, notice that when we start here and then we go back to it, the r values is equal to 0. So we're going to let r equal to 0, and we're going to solve for it. Divide by 4 on both sides. Cosine of 3 theta equal to 0. Now cosine of an angle that equal to 0, there's only 2 options. It is either here cosine equal to 0, or here cosine equal to 0. So in that case, the angle have to be equal to pi over 2 plus extra 2 pi into it. So we just add multiple pi and pi. In this case, because here pi over 2 plus a pi go to this, plus a pi go back to that. So theta equal to pi over 6 plus n over 3, n pi over 3. Right. Then we can choose. If we choose n equal to 0, then theta equal to pi over 6, which is this line. And we choose n equal to 1, we have pi over 2, which is next, and then this. Bottom line is, if we choose pi over 6 here, and the other one will be negative pi over 6. If only one half of the petal, only this area, that area is equal to 1/2 integral from 0 to pi over 6. And then from now perspective, if we look from the center away from it, we always see the function. So going to be 4 cosine of 3 theta. We don't need the calculator anymore. Square minus the inner function 0 square d theta. Right, if we want the area of the whole thing, we have to multiply by 6 at the end, because we only calculate half of it, half of the panel. We need 3 of them, which is 6 of them, which means 3 0 pi over 6, and that will be 4 square, just say 4 cosine of 3 theta square d theta. Right, so that's what we have for that one. Right. Skip 12 and 13 and we have to do that in class. Next we have the parabolas. Right. For the parabola, this is the vertical parabola. In general, it's either, I just want to write the formula, y squared equal to ax, which means it is the sideways parabola. And x squared is going to be up and down. Negative is down, positive is up. So this one is a parabola that open down, and this is a parabola that open to the right. Right. Now it is easy to see that when x equal to 0, y equal to 0. So we have the 0, 0 here on both cases. Next, of course, we can choose somewhere for y and then so for x. The easiest one to do is just pick a point, really, but the answers are for the focus and directrix as well. Right. Now we deep dive in the equation. Is either y squared equal to 4p x or x squared equal to 4p y. If it's positive, in this case, open to the right. If it is negative, in this case, that open down. Right. Now, the 4p though, what is that? 8x, so obviously here, if we match, this is going to be equal to 8. So 4p equal to 8, which means p is equal to 2. So why do we need that? The p equal to 2 here is the distance from the focus to the directrix. I'm sorry, the distance from the focus to the vertex and from the vertex to the directrix. So first, the point on the graph, this is going to be the vertex, 0, 0. Now it's going to be 2, meaning this one open to the right. So the focus is going to be on this side and the directrix will be on this line. So that is the directrix is x equal to -2. The focus here, so the parabola we open that direction. Again, y equal to positive, y squared equal to positive x, that's going to be to the right. And this one, the vertex is here, and we're going to match that with the -12. And so 4p equal to -12. So the focus is going to be 2 and 0. So p is equal to -3, which means from this we go -3 distance we'll get from the vertex to the focus. Now -3, so we're going to be here, and that is the focus of 0 and -3, and the directrix is on the opposite direction of the focus, so it's going to be y/3. Right. And so we have the parabola open like this. Right. Again, the vertex, both of them at 0, 0, and then from the vertex, the same direction to the focus. I mean the same distance from the vertex to the focus, and from the vertex to the directrix. And if we start with y square, it's going to be left and right. X square we will be up and down. Simply y equal to x square. It is the parabola that open up. If it's negative, it opens down. Right. Next we'll go to the vertex. It just have an intercepts. So we have negative 5 and 5 and 6, 0 and 6 and negative 6. Notice that because of the ellipse is symmetric, so in this case the center has to be in the middle, 0, 0, and so the ellipse kind of like this. So pretty much we're going to write the equation of the ellipse of x squared something equal to 1. Here's something square, and here's something square, and whatever that something is, it's going to be the distance from the center to the point of the ellipse. Now we go left and right 5 units, 5 units left and right. So that's where I'm going to put 5 under the x. X is the horizontal distance. Y going to be up and down. So we go up and down 6 units. So we have that x squared over 25 plus y squared over 16, 36 equal to 1. And that's what we have for that one. Right. Even though they just give us the intercepts, but we know that the ellipse, it have to be symmetry, and there's the center, and so they have to be 0, 0, and the ellipse go around like that. Right. Now this one we have the vertices and the foci specifically though. The vertices 6 and 0, negative 6 and 0. So 2 vertices here and here. 2 foci, negative 5 and 5. So we see the distance from, first of all, because of symmetry again, the center have to be right in the middle. And then we have the distance from the focus to a center is 5. The distance from the center to the vertex is 6. Right. Bottom line is we're going to have the equation of x squared over something square plus y squared over something square equal to 1. Now, we know that from the center we go left and right 6 units. So we know 6 is going to be below the y x squared. So it's going to be x squared over 6 squared. Right. Just need to determine this. We don't know what that is, so let that be b. This is 6, and this is b. Right. Next, from the center to the vertex, that distance is going to be a. So that is a. And the distance from the center to a focus is going to be 5. So that is c. Alright, so what is the relation between A, B, and C here? One thing we know is A is the biggest one of them all. So we're going to have A, don't put that, A squared equal to B squared plus C squared. A 6 squared, B squared, don't know, C squared is 5 squared. So we solve for B and we have B squared is 11. So b is square root of 11. Right. So put it back into the equation. X squared over 6 squared, which is 36, and b squared actually just 11. We don't even need to take the square root. So we have the equation like that. If we want to graph it, it will be up and down square root of 11 units. So a little bit more than 3. So kind of like that. Last question is about the hyperbola. So we have 2 vertices and 2 foci. The vertices is at 2 and -2, right? And the foci at 3 and -3. There's different color here. Notice because of the symmetry, again, the center is going to be here in the middle. Right. So hyperbola, the ellipse is easy. The sign in the middle is a plus. Hyperbola is the minus in the middle. So I'm going to write like that. Or it could be y squared Now, first determine quickly which one is going to be. Right. Now, just choose the point 0 and 2, for example, the vertices belong to the graph. So if we put 0 and 2 in here, remember x is equal to 0, y. If you put 0 in for x, and that's going to be 0 here. Except I plot that incorrectly. Sorry. Let's do that again. 0 and 2, 0, -2. Sorry, the vertex should have been here. And 3 and -3. Okay. So not that. Sorry. So that's good thing that we check. And what we actually check is if we put 0 in for x and y is 2, this equation doesn't work because negative equal to a positive number. So we have to keep this equation for the square. So it's going to be in this form, because when we put 0 in for x, it indeed is equal to 1, which is good. Now, for the hyperbola, this is going to be the distance that we go up and down to go to the vertex. So that is going to be 2, because from 0 to 0, 0 to 0, 2, that is 2 units up and down. So we're going to put the 2 here counterfully under the y. Right, next, from the center to the focus, that is going to be 3, and we let that distance be c. Notice c is always the distance from the center to the focus. Center to the focus is c. c equal to 3. And in this case, 2 is equal to a. And notice that in the hyperbola, c is the biggest one, not a. On here, a is the biggest one. On the ellipse, on the hyperbola, from the center to the focus is the biggest distance. We don't know what it is, but we do know that c is the biggest one, will stand by itself. So c is going to be 3 square, a is going to be 2 square, b we don't know, but we can solve for that easily, which is b square root of 5 though. So we can put b square root of 5. We can put square root of 5 here. And bottom line is we have y square over 2 square, which is 4, minus x square over 5, which is 1. And that's what we have. So y square minus x square is going to be vertical parabola. So if we want to graph it, we go up and down 4 units, 2 unit, left and right square root of 5 unit. So we're going to have like a little box, and then we wrote the diagonal. The diagonal would be the asymptotes, and hyperbola will be fit inside. We know that this one y square, and it will touch the vertices at those points, so it have to be like that. Right. So that's all we have for this review. It's quick. We do not have test 4, just have the final, and only a few questions of this will be on the final. I hope you find this helpful. Thank you for watching.